Now I have to be really excited. I get to question 11. It's like, woo, marathon time. Okay, phone calls, interruptions, dog barking, cat biting, etc., but I'm getting to the end of it all. So, and let's remember it's 2018, not 2019. Let's just get my head around what it's all about. X is the astronomical units, the distance, and Y is the amount of radiation. So Mercury is closer to Jupiter, and I can also see that it has stronger radiation because it's closer. It's kind of obvious, isn't it, really? It says the intensity of Y is proportional to the power of the distance x. Write down the equation of Y in terms of x and the two constants. Right, so it's proportional. So it's just a proportional one. So it's Y equals kx to the power. Okay, to the power. Let's call it n if you want. Oh, so that's the question there. That's number 1 done. And then part 2, what's part 2 say? Show that the equation can be written in this form here. Oh, okay, so they've natural logged both sides. So if you learn this one, and then I'm going to learn here. So I'm going to do it all in one big go, but then that can drop down, can't it? That can drop down, and because it's multiplying, you've got a whole bunch of stuff here as well. So let's just work through that one. So ln y equals ln k plus ln x to the n, and then ln y equals ln k plus n ln x, and that's what we've got there. Brilliant. Okay, doing well so far. Happy days. What about section 3? It says section 3, in the printed answer booklet, complete the table. I don't have a printed answer book. So what am I going to do? Complete the table. Right, okay, I'm going to just sketch this here quickly and then come back to you. Right, I think this is what the question is, like this. So literally, I'm going to learn each of those ones. So, and then question 4 says, use the values to find A and B. Okay, so I need to find B, which is here for me. So how do I want to do that? Okay, so I'm literally going to do, I can look at the gradient, because that is the gradient, isn't it? So I'm going to do y1 minus y2 over x1 minus x2, boom. So that's what I'm going to do. So I'm going to do y1 minus y2, that minus that, divided by that minus that, and that will give me my gradient, because that is my gradient. Okay, remember how to do that? So it's literally going to be 9.575 minus 4.022, all divided by minus 1.179 minus 1.599. So I do that on my calculator. Okay, so welcome back. So I press equals on that one and I get minus 1.9989 dot 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 dot. So that is minus 1.999, and that's my gradient. And then the constant, how to find a constant, that's relatively easy now because I can shove everything into my equation that I've got. And so I can do ln y, so do it here, 9.75, oops, minus, be careful about rounding up, I think, really. That's what you have to be careful about. Always be careful about your rounding up. 218. Okay. There are different ways of doing that. on the solutions to do that. That's just the way it's gone here. And then question 4, use your values. Done that. Question 5, hence rewrite the equation using suitable numerical values for the constants. Okay. So I need to rewrite this equation now. Okay, so y equals, now in order to do this, I've got to go backwards. So let's just say learn y equaled 7.218 minus 1.999 learn x. So I do the exponential functions of these in order to get back onto it all. So I need to find k, and I know what learn k equals. Learn k equals this. So therefore, so e to the 7.218, that gives me my k value of 1364 x, and that was my b value, which I've got as that, so I'm just going to say is minus 2.00, and that should be sufficient. That should be sufficient. Yeah, good. Then it says sketch the graph of the function here. Right, now obviously my calculator can use that negative, so it's going to slope down like that. It's never actually going to asymptotic to that line there, so it's never going to be touching here. So it should look like that. So there you go. And then lastly, Earth is 1 astronomical unit from the sun. Find the intensity of the sun's radiation for Earth. Okay, it's all a bit crowded here. So let's just delete everything here. And I know that x equals 1. So I simply just put 1 into this value here, and I should be fine. So for Earth, our mother planet, 1 to the power of ... anything, it's just going to be that, isn't it? So there you go. Done it all, guys. Take your time, go through it all. Hopefully it's helped.